This is section 1.2 continued, and we're in video 2. And again, we're talking about the basics of functions and their graphs. The first thing we're going to review is evaluating a function. So it's working with our function notation. Here's a couple examples let's take a look at. The first thing is finding f of 3 for f of x equals 2x squared minus 4. Now remember, because the 3 is in place of the x in f of x, the 3, remember, replaces the x if I was to write this as f of x. I'm going to go ahead and take the 3 and put it in place of all my x's. So we'll say f of 3 equals 2 times 3 squared. Remember, we replaced the x with a 3 minus 4. And now we'll just evaluate. We'll just see what that equals. When I square the 3, I get 9. So I get 2 times 9 minus 4. 2 times 9 is 18, and 18 minus 4 is 14. So in this case, f of 3 is 14. We'll do the same thing again for the next one. We're going to go ahead this time and find f of negative 2, and we have a new function here. So we're going to put the negative 2 in place of the x. So we'll say f of negative 2 equals 9 minus negative 2 squared. And from here, remember, you just have to make sure you follow the order of operations correctly. In this case, we'd want to do the exponents first. And negative 2 squared is positive 4, so 9 minus 4 is 5. And f of negative 2 in this case would be 5. So these are some pretty basic examples of just replacing the x with whatever number we're given. Let's go ahead now and make it a little bit harder. So now in this case, we're going to continue to evaluate, only now we want to replace x with x plus 2. So wherever we see an x in our equation, we're going to replace it with x plus 2. So it looks like we have to put it into two different spots. So we'll say f of x plus 2 equals x plus 2 squared minus 2 times x plus 2. Remember, when you replace it, you want to make sure to put it in parentheses so you follow your order of operations correctly with distributive property and things like that. Now that we have it written out, we want to go through and do some simplifying here, so some basic algebra skills. The first would be squaring x plus 2. Now, as a side note, we want to take a look at x plus 2 squared for a second on the side here and do just a quick reminder. Now remember, this does not equal x squared plus 4. You can't just square each term. Instead, we want to use the distributive property or FOIL or the rectangle to multiply x plus 2 times x plus 2. And when I do that, we're going to get x squared, 2x, 2x, and 4. So that equals x squared plus 4x plus 4. So going back to our example, x plus 2 squared, using that rectangle, is x squared plus 4x plus 4. Now we'll distribute that negative 2 and get negative 2x minus 4 and a plus 4 there at the end. Let's go ahead and see if there's any like terms to combine. And I see the positive 4x and negative 2x equals 2x. Positive 4, negative 4, and another positive 4. Looks like we're going to just end up with a positive 4. And so this would be our final simplified answer. Continuing on with evaluating functions, we are going to be finding f of x plus h for a number of different functions. Now, this is going to become very important to us as we continue on throughout Chapter 1 when we start using what we call the difference quotient in Section 1.3. Now, you'll notice in this case we don't have any numbers in here. The last example, if we go back for a second, the last example we were finding f of x plus 2. Now the 2 is being replaced with an h, so we're finding f of x plus h. I'm going to take that x plus h and I'm going to put it in for all of the x's and just simplify. So this is just going to be a lot of algebra skills and combining like terms. So let's go ahead and try the first one. We have f of x equals 2 plus x. So we're going to go ahead and take that x plus h and just put it right there into that x. So we're going to have 2 times x plus h. And here, some basic distributive property tells us that the answer is going to be 2x plus 2h. Moving on to the next example, almost the same, just a tad bit further. Now we're going to take that x plus h and put it in right there. So we just have that plus 1 at the end. Why don't you pause your video and try this one, and then you can check your answer in just a moment. Hopefully you ended with 3x plus 3h plus 1. Notice that the 3 only got distributed to the x and the h, not to that 1 outside the parentheses. Our final example is the most complicated of the 3, and that is because we're going to have to do a little bit of squaring. Again, it's all just our algebra skills though, so it's actually not that much different than the previous example we just did on the previous slide. So again, we're going to take that x plus h. It's going to go in 2 places there and also there. So we're going to have to be squaring x plus h. So let's go ahead and first write out what we're going to need to do. So we're going to have x plus h, and we're going to have to square that first. And then we're going to have to multiply x plus h by 2. So let's go ahead and on the side of our paper use our rectangle to solve x plus h squared. So it's going to be x plus h times x plus h. In the top corner, we're going to get an x squared. We're going to end up with 2 xh's and an h squared. So our final answer, x squared, 2 xh's, and an h squared. Now, I want to take a moment to talk about squaring a binomial, meaning squaring something with 2 pieces like this. And hopefully in the past 2 times we've done this, you've seen some patterns. So if you want a shortcut to not have to always use the rectangle, here's a rule you can remember. If you're squaring 2 things being added or subtracted, so a plus b squared, and let's rewrite that a little bit better. So we're going to square 2 things like a plus b. In the top corner of your box, notice we got the x squared, the x times x. So the very first thing you're going to end up with is the first thing squared, like in this case the a squared. Now across our diagonal we got those 2 things inside multiplied together, but there was 2 of them. So you're going to get 2 of the things being multiplied together, so a times b. And then in the bottom corner we get the last thing squared, so it would be b squared. And then that is kind of the rule if you want to square a binomial, a shortcut. You square the first thing, multiply the insides together with a 2, and then square the last thing. You can use this shortcut, or you can use the rectangle. It doesn't matter which you choose. You can go either way. Let's do a quick example just using the shortcut before we continue on that previous question. If I want to square 2x plus 4. So the shortcut says square the first thing. When I square 2x, I get 4x squared. Remember, you have to square both parts. Then I'm going to multiply the insides together. That will give me 8x. But I have to multiply it with another 2, so I actually get 16x. And then you square the last number, 4, and that would give me 16. So just a shortcut. Now, can you still draw your rectangle and go the way we've always done? Of course. But if you want to square things a little quicker, this is a good option. So let's return to the example we were doing though. Now that we're done with that, we're going to take this x squared, 2xh, and h squared, and we're going to put it in for our x plus h squared. We're going to distribute that 2, so we get plus 2x and plus 2h. And it looks like, if I look through there, nothing can be combined. So even though this is a big, long mess, it's as good as it gets. And there's your answer when we're evaluating that function. All right. Moving ahead, I'm going to give you a multiple choice question. So why don't you take a minute here. You're going to find f of -1. And when you're done with that, that answer will go onto your Google form. All right, now we're going to talk about the vertical line test. And the vertical line test is used when you want to identify if a graph is a function. So if you have a picture of a graph and we want to know if that picture is a function, we can use the vertical line test. The way it works is you draw a vertical line, they're drawn in red here, anywhere on the graph. Anywhere on the graph, if your vertical line touches more than once, then we say it's not a function. If your line only touches once, then you say, yep, in fact, this is a function. And so it's that simple. You just draw a vertical line and then see how many times it touches. So let's look at some examples. Let's just look at this first one. If I draw a vertical line somewhere on this graph, I can see that it crosses 2 times. So that means no, this is not a function. But on the next one, anywhere I draw this vertical line, anywhere I want, if I draw a vertical line, it only crosses once. So in fact, yes, this one is a function. Why don't you try these next ones? Pause your video, see what you get, and then we'll go over them. All right. Hopefully the first one's easy. Drawing a vertical line, we cross twice, so we say no, not a function. Now the next one's a little trickier. This is what we call, if you don't know this is a step function. Now some of these spots, let's just pick right here at x equals 2 to draw a vertical line. Now it's tricky because it looks like it crosses twice. So if you answered no, I can see why you answered no. But because there's an open dot there, that means we're not including that spot. Someone took a hole punch and they punched out that hole. It doesn't count there. But it is filled in up there. So really it only touches there once. So in this case we'd say, yeah, this is a function. All right, moving on then, our final objective, and this one's pretty important, and this is going to come back a lot throughout the rest of this chapter, and it's a lot of just knowing notation. We are going to obtain just information about a function using this graph. So we're given a graph of a function, and we're just going to basically answer some questions about it. And I just answered the first one. The question is this a function? And if we draw a vertical line, we can see it only crosses once. So we say, yes, this is a function. Now the next question is to find f of 4. Notice the 4 is replacing x. If I was to say f of x, the x is getting replaced by 4. So basically that means go to the graph, look at x equals 4, and what is the y value? And I see the y value at x equals 4 is 0. So f of 4 would be 0. The next one, doing the same thing, f of 1. If I go over to x equals 1, I notice we're down here, it looks like at -3. Now this last one's a little different. Now we want to know for what value of x is f of x -4. This time we're being given the y value. We're trying to find the x value, so we have to go the other way. So let's go ahead and take a look at our graph. We're going to go to y equals -4, and y equals -4 would be this spot right down here. The only place it crosses is right there, and that x value is 2. So x equals 2 is where f of x equals -4. So again, this is just all about analyzing the graph and really knowing the differences in our function notation. All right, here's your free response question. I want you to find f of 7, so go ahead, pause your video, and look at this graph and find f of 7. Now you'll notice there's no scale on here, so let's just make sure that we know we're scaling in ones. So 1, 2, 3, etc., and the same going up. Find f of 7 and put that answer into your Google form. And then this is where we'll be ending our video for the day.